Hello dear viewers and welcome to my session. My name is Anton Boyko and today I would like to talk to you about Microsoft Azure Chaos Engineering. You can see my email here if you will have any questions after the conference about this topic or about Microsoft Azure in particular. Feel free to write me an email and I will do my best to help you to answer those questions. So, the first question that we need to answer before we will actually proceed to the content of this session is, what is chaos engineering in the first place? And to be honest, I would like to take a step back and I would like to take a look at the similar but yet different question. I mean, like similar in nature. What is DevOps? Here we're all at DevOps Stage conference, so let's try to answer this question first. So when we're talking about DevOps, the thing that I was saying for the last maybe 5 years or even more is that DevOps, it's not about the tools. It's not about containers, not about Docker, not about Kubernetes, not even about cloud. DevOps, it's about the people, the culture, the mindset. When we are talking about chaos engineering, it's the same stuff. It was never about the tools. It was never about the cloud or about the containers or something like that. Chaos engineering was always about the people and the mindset. Let me give you an example. Let's say that you have a company. You are working at that company. You have a project in that company. And this is, I don't know, like a service that you provide to all of your customers, and they use this service to do some stuff. So the thing is that in one hand we can say, you know what, in case something will go wrong with the service, we do have, I don't know, like a team that is always on a standby, and in case it will be a failure or something like that, the team that is on a standby will just jump in and fix everything. So in a way, let's say a firefighting team, okay? But on the other hand, we can say, you know what, it will be really expensive actually to keep that firefighting team. So let's try to do something different. Let's try to run as many fire drills as possible to identify what are the weakest points of our application, how and why our application can fail, and then try to do something with that. So basically, even when the actual fail will occur, you will know how to exactly proceed with that. So when we're talking about chaos engineering, first of all, it's about people and about the mindset to invest upfront, you know, about the mindset that it will be extremely expensive to fix this issue on production. It will be much cheaper to actually try to address this potential risk, potential issue during the design or during the coding phase or something like that. We can actually take another look at that. We can actually consider chaos engineering as a part of our quality assurance process, because we need to make sure that our application is available. So this is one of the questions that is basically in the area of quality assurance, and how we will test that our application is, for example, resilient, how we can test that our application can tolerate that, I don't know, 30% of the computer sources will disappear due to an issue, how we can ensure that our application, for example, can tolerate some network issues and so on and so forth. And the answer here is with the chaos engineering practices. If we will take a look at the Wikipedia, then we will see this official definition. Chaos engineering is a discipline of experimenting. So the experimenting is the first important keyword here, is that you need to create and run your experiments. Discipline of experimenting on a system in order to build confidence. Again, the same as in the quality assurance process in general, you need to build enough confidence to make sure, okay, I'm not afraid to run this application. enough confidence in the system capability of withstand turbulent conditions in production. Why in production? Because again, if your system will fail on non-production environment, that's okay. That's what's happened basically every day, and maybe even not once per day, maybe even like 2, 3, or 4 times per day. You don't care about that. You don't care if your test environment failed, but you do care if it failed on production. So let's take a look about what the fault injection means. The fault injection is actually one of the practices that you can use to help you to emulate those fault conditions and to introduce some chaos to your system. So you have a chaos management tool, you design your experiment, you design your chaos experiment, and then you basically apply, or let's say run, that experiment against your target environment. Here on this picture I'm showing how to do that on production, but believe me, that's not what you should do at the beginning. At the beginning, I will highly recommend to have a production-like environment and run those experiments there. Nonetheless, you run an experiment, you basically, on purpose, unplug, like in this case, a virtual machine, maybe unplug a SQL database or something like that, and then you monitor, you observe, and you log everything that is happened there. And then, as soon as the experiment is over, your chaos management tool will kind of undo, it will roll back all of those changes, so the system will actually get back to original working state, assuming it was working before. Of course, the value of this approach is that our app becomes more resilient, but what is also more important is that because we're continuously running those fire drills, we are able to detect our failures much faster, and we are able to create something that will help us to fix that issue much faster. And of course, how you can measure the success of the implementation of this practice in your project, in your organization, is first of all with the MTTR, mean time to recover from a failure, and also with the overall availability. So the MTTR basically should go down. You should be able to recover from the failure much faster. Why? Because you already run the same kind of a failure on your non-production environment, and potentially you've created some remediation steps, you've created maybe some automation, you changed your hosting model or something like that to help you basically to tolerate that issue, to tolerate that problem. And that's, of course, increases the availability. In some cases, I was talking to a lot of different folks about that. In some cases, to them, it may look like doing random stuff. Well, this is entirely not like that. I mean, like, it's the same as saying that when we're having a quality assurance engineer working on a project, then that person is also doing some random stuff, trying to, I don't know, like, break the application. Yeah, in some cases it's exactly like that, but to be honest, the quality assurance discipline in general, it's much more than just clicking a buttons and hoping that the application will fail at some point. There are a lot of other steps that needs to be taken before that button can be pressed. So we're not just doing that randomly. We're always having a purpose, we're always having a scenario. The same here. If you will try to, I don't know, like unplug some of your virtual machines randomly and then see what will happen, well, to some degree it will help you to understand how your system can tolerate that, but still, you always need to plan. For example, if I will unplug those machines, what can be the reason why those machines are unplugged? For example, I can unplug the SQL server, and that can emulate a scenario when I need to take it down to do some updates, okay? Or you may say, okay, you know what? We have, for example, this physical hardware, or we have this virtual data center, and we have our virtual machines deployed in 2 different availability zones. Let's try to unplug the entire availability zone and see what will happen. If we have more than one, let's try to unplug the first one, and then let's try to unplug the second one, and then the third one, just to make sure that no matter which exact availability zone will fail, we still be able to produce the same results. We'll still be able to operate, or if we will fail, then we will fail, let's say, in the same manner, no matter which exact group of those resources went down. The other misconception that I always see a lot is that, let's say, there already may be a culture in a company or in a project that when the incident occurs, we basically throw all our resources to fix or to recover from that incident, and then after that we have a culture of doing the postmortem, and basically we're trying in that case to identify what was the root cause and maybe also do some remediation so it will not happen again in the future. Well, the chaos engineering, again, it's not the same as well-established postmortem practice, because the postmortem is still more about reactive, and the chaos engineering is more about proactive way of working. With the postmortem and with the, let's say, the traditional way of working, when you have an incident and then you, as I was saying, throw your entire team to fix that, and then you're analyzing what was the root cause and try to do something that it will never happen again. Here, you are trying to break your system on purpose, and before the actual incident happened, you are trying to create a remediation plan how to prevent that. Let's take a look at the few examples. So if we're talking about the reactive approach, let's say that you had a fire, like a physical fire in your building, in your office. With the reactive approach, what you would like to have, you would like to have maybe like a faster firefighting car, so when you will call the fire guards, they will drive to your office faster, and therefore they will be able to, let's say, put the fire down faster. But with the proactive approach, you may want to invest upfront to have some automated sprinklers, so as soon as there are, like first signs of fire, the automatic sprinklers will just start sprinkling the water or over the building, or maybe not the water explicitly, but nonetheless starts to sprinkle that water all over the building, and in that way they will kind of prevent the actual fire from happening. Again, when we are doing the reactive approach, you may say, you know what, we would actually like to rent our office as close as possible to the fire station, because, again, it's also a valid assumption that if you have a fire fighting team in the next building, then that will be super fast for them to get to your building and start basically fighting that fire. But as an opposite approach, what you can do, you can say, you know what, even though the firefighting teams are at least 10 blocks away from our building, we would still like to run some fire drills. Maybe they will not help us to prevent the fire, but at least they will show us what we can expect. They will show our team what to expect when the actual fire will happen. And when the actual fire will happen, it will not be, like so big stress for them, because they run those drills up front. They know exactly what needs to be done to put that fire down. And also, when the actual fire happen, and when you basically, put that fire down, the thing that remains for you is to somehow recover from the ashes. When you are working with the proactive approach, you are always aiming at preventing the fire in the first place. Technically, what we can basically say about that, to sum everything up, we can say that the chaos engineering, it's like the next step. It's like an evolution of doing a well-established post-mortem ceremony, when you, as I was saying, investigate and try to create a remediation plan. So chaos engineering is just the next step in this evolution. And again, I was saying that the chaos engineering is basically a part of the QA process, and let me actually try to show this example to basically solidify my point even more. So you have the requirements analysis. When you're doing your chaos engineering, you also need to analyze your requirements, because your requirements may be that our application should tolerate when, I don't know, let's say one of two database servers are going down or something like that. Then you need to plan your tests. So first of all, you need to plan how exactly you will take your database down, and second, you will need to create basically a plan on how you will check that the application is still able to work even when the database went down. Then you need to develop those different test cases. Then you need to set up your testing environment. As I was saying, if the organization is mature enough, they can run the chaos engineering directly on production, but still I will highly not recommend that as your first step, because I am 100% sure that you will be able to break your production. Unfortunately, I'm not 100% sure that your production will be able to recover from that failure. So yeah, please try that on non-production environment first. Then you need to execute your actual tests. And then, of course, the most important part, monitor and learn. And because you're doing that upfront, again, I cannot stress that highly enough, because you're doing that upfront, you are able to build enough confidence before you will run into those issues on production. Saying all that, let's actually switch to Azure portal and see how that can work with Azure resources, what kind of experiments you can plan and execute there, and what kind of tools you have there that basically can help you to run all the above mentioned. For this demo, I have a bunch of resources set up in Azure. First of all, I have my Azure function, which basically two endpoints, read and write, and this function is connected to the Cosmos DB database. I can actually switch here and show you how it works. I can run a read query and query some data from my database. As you can see, by default, I kind of put some IDs here, and this is the record I was looking for. Or I can send the write request and it will generate a random record, save it to the database, and then return it back to me here. But the point here is that we do have both the read and write endpoints. Here I have my Cosmos DB database, and as you can see, it's configured in the following way, that I have two regions, East US and Central India, and both regions are enabled for reads and writes. If you remember how Cosmos DB works in the first place, it automatically will redirect me basically to the closest region. My function, by the way, is deployed in East US, so by default it will use the East US read and write endpoints. What I have next, I have my live metrics. We will be using live metrics to monitor what will happen during our experiments. And here I'm also having my load test, which will run in only one user mode, but that load test, it will send read request, following by write request, then the read request again, and so on and so forth. So we'll kind of, do some emulation, and even in one user mode still, you will be able to see the difference during our experiment. So I mean, like, it's there is no need to run more than one user actually for this demo. And here I have my actual chaos test. So let me actually click edit and show you what I have inside. As a part of this experiment, I can set up steps, I can set up branches. The idea here is that all the steps will be executed in sequence all the branches within the step will execute in parallel. This is a very simple example. I have only one step, only one branch, and here I've already added my action, and my action is Cosmos DB failover. Let me edit it here and show you how it was configured. So as you can see, the type of the failure that we will be injecting in our system is the Cosmos DB failover. But if I will expand this guy here, you can see that actually there are a lot of other kind of failures that you can inject into your system. And it will run for 10 minutes and it will fail over to the central India. So we will kind of, shut down, or let's say emulate the error in East US, and we will force Cosmos DB to use Central India endpoints only. And in my target resources, as you can see, I have my demo chaos 01 Cosmos DB database. So what we will be doing now, first of all, I will go to my read-write test and I will run the test again. I just want to show you a few things on the live metrics dashboard, so that is why I will run this test again. And it should be here. Yeah, it's provisioning and it will run momentarily. Meanwhile, what we can do, we can switch to the live metrics dashboards, and we will see basically that at some point the request will start to come in and all of our metrics will start to change from zeros to something else. Okay, as you can see, it's exactly what is happening right now. So I have my request rates here, I have my request duration, and so on and so forth. And the most important part that probably worth mentioning right now is if you will take a look at the chart below, at this line below, you will see that currently we're handling around like 42 requests per second. The function is deployed to East US data center and the database is also in East US data center. What I will do now, I will go to my chaos experiment, I will run my experiment, and then I will get back to my dashboard. And you will be able to see that at some point it will need basically maybe like 30 seconds or something like that to warm up and run the actual experiment, but you will be able to see that due to a failure we will be redirected, we will be forced to fail over to a total different data center, and the data center is located basically half across the globe. But if you highlight it, I would like to make here is that first of all, due to how Cosmos DB is, we don't need to manage any configuration for that. This is only basically one endpoint that we are using. As you can see, we're not redeploying, we're not changing the configuration of our app, nothing like that. And then we'll be able to see that the application will still continue working. The expected behavior is that it will slow down, but it will still be working. Let's use some magic of the cinema, and yeah, I was about to actually say that I want to fast forward that a bit, but as you can see, there is no need for that, because what is happening right now is that before we were running around like 40 requests per second. Now, if you will check that below, we're running around 4 requests per second. There were a few errors in our dependency call failure rate, but that's fine because by default there is a retry policy implemented. So everything is running as expected, but as you can see now, it's running much slower. The other thing that I also want to show you while that thing is running, I would like to show you basically my previous runs for this experiment. So this is the load test baseline that I'm having here, and as you can see on this baseline, the response time from my function, it actually went up and down, but it went up and down between 20 and 60 milliseconds for the HTTP request. This is still can be considered as a super fast, especially also considering that I'm using the cheapest possible pricing tier for my Azure function. And as you can see, the amount of requests per second, this was more or less, let's say, a flat rate. the same amount across the 20 minutes experiment. And if we will scroll down below, here we will see that from the Azure function side there were no errors, and everything basically runs silky smooth. Now this is, as you can see from the chart, this is my second run now with the chaos engineering injected during the load test. So here I've injected my fault, and as you can see, before the fault was injected, everything was more or less on the same level. The ratio between the request and response per second, the performance metrics here were also more or less on the same level, but in the middle we have a huge gap because we were forced to fail over to another region. And if I will scroll it down, you can see basically the same things here, but 0 errors due to the retry policy, 0 errors here, just an increased response time. And if we will compare those two results on the same dashboard, you will basically see exactly the same things that I was mentioning before, that despite we've injected the failure, the current configuration that we're having in Azure allowing us to basically still continue to operate. Of course, we can configure some additional monitoring. Of course, we can say that we want to maybe send some alerts. And to be honest, if we're already having our Cosmos DB database deployed across 2 regions, then maybe we should have our Azure function also to be deployed across 2 regions, and in that case that will not be an issue because we can put something like a front door in front of that and route all the traffic in case of a failure to the central India region to basically hit both the application host and the database that is deployed there. But this is how you can test the built-in features of the platform itself. I mean, like if you're using something like the virtual machines, then you can imagine that you can always shut down the virtual machine, and that's basically it. It will kind of emulate the failure, at least to some degree, but in this case we're working with the managed service, and it's not an easy to do that on the managed service, but here it is. This is how you can do that, how you can inject a failure into managed service and then see how your application will react. Will it be able to continue working with that failure injected or not? For the second demo, I would like to show you a bit different way of working with failure injection. So the idea here is that in the first demo, I was showing you how you can do that with the managed services, which is extremely tricky. But here in my second demo, I have a virtual machine and I want to inject something different to that virtual machine. Let's say that the scenario here may be the following. You had maybe like a lift and shift migration project, you moved your application to the cloud, and now everyone seems to be extremely happy about that. But the thing is that you may be having like an old and legacy setup, and in that old and legacy setup, which is usually also an ugly one, you may have like more than one application installed to the same virtual machine, and therefore you are not truly in control of, like the demand and the actual amount of resources that you have for each of your applications. So the thing here is that I have my second experiment. Let me show you what I have inside. Inside, I'm emulating quite an interesting failure. Inside, I'm actually emulating a CPU pressure. So let's say that, as you can see, the type here is CPU pressure. Let's say that for 10 minutes, I would like to emulate 95% of the CPU load. And then, while I'm emulating this failure, I would like to check how my application will react. Will it be able to work in general, and so on and so forth. Let me show you a few more blades here. So this is my virtual machine, and as you can see, this is actually a pretty small and relatively, let's say, common virtual machine in Azure. I have only one CPU, I have 3.5 gigs of RAM, it runs Ubuntu version 18, but I would like to go to this extension tab here and show you the following, that I have 2 different monitoring agents set up there. You don't need to pay attention on that, but what I also have here, I have the Chaos agent. So this is an integration agent that I set up front to this virtual machine, and the Azure Chaos Studio will be able to communicate with this Chaos agent and then inject this failure directly to my guest operation system. What I have here, I have a dashboard which basically shows that currently the average CPU load is less than 2%, which is fine. So let's see how it will change when we will inject our failure. So we're going here and we are running this experiment. It will run for 10 minutes. For those 10 minutes, it will emulate basically the 95% CPU load. And what we will be doing, we will be basically just sitting here, checking what we have here on a dashboard, and we will basically see that this graph will go up. At the same time, what we can do for this virtual machine, I have an Nginx web server. So I can copy this domain name, go here, and welcome to Nginx. This is the default setup with only one page, so we're not basically expecting that the 95 CPU load will affect this in any way. I mean, like, at least it will still be able to work. So what we will be doing now, as I was saying, we will switch to this graph here, and again we will use some cinema magic to do some fast forward, because probably you don't need to just sit here and wait for 10 minutes while this experiment will run. Okay, our test ran for some time. Unfortunately, there is no auto update on this dashboard, so that's why I need to do the manual refresh. But what you will be able to see, you see that the CPU utilization actually went to 95% as expected, and it's basically still there. We can go here, we can try to refresh this page a few times. We can see that basically everything is working as expected. What we can try to do as well to basically ensure that it's not a cache or something like that, we can open a new in private tab and open it here again. As you can see, even in private mode, the Nginx is able to respond. So what kind of a conclusion we can make from that one is that basically even with the 95% CPU pressure, the Nginx is able to perform in one user load mode. So what we will be doing now, I will get back here, I will wait for this experiment to finish, again with the fast forward, to show basically that after that the load will go back down to 0. At this time our experiment should actually finish, so let's refresh again and see is it true or not. Yep, it is true. So as you can see, this line basically went down. That means that our experiment finished and the CPU load returned back to the expected, or let's say, I don't know, like regular value, and the regular value was a bit less than 2%, if you remember, before we started the experiment. So the thing that I would like to show again is that there are a bunch of different kind of failures that you can inject in the same way through your target virtual machine. This is the CPU pressure, the disk pressure, and the memory pressure, the network latency, and so on and so forth. So those things, they are usually not easy to emulate, but through this integration you can do that. And you can inject the same kind of failures also through your VM scale set. If you're not running a single VM, if you're running the VM scale set, this is also available. For this demo, I have my application deployed to AKS Azure Kubernetes service, and this is what I have there. So I have my first namespace kube system. This is of course everything that we need to run the Kubernetes itself, but then I have the next namespace, chaos testing. So with the chaos testing namespace, I am basically deploying a few things required to run my failure injections within the Kubernetes itself. Microsoft is using this tool in particular, the Chaos Mesh tool, the well-known tool across the community that uses the Kubernetes. Technically, you can use that tool not only in Azure, you can use this tool to inject your Kubernetes failure into any Kubernetes setup. But nevertheless, because we're talking about Azure, so yeah, this is what Microsoft is doing. And then I have two more namespaces. I have the Azure Vote namespace, and for Azure Vote namespace, I run the demo voting application. It looks like this, so I can vote for cats, I can vote for dogs, probably I will vote for cats again, and then I can reset it. Just a demo app. And also I have my catalog API deployed to the default namespace. I'm basically running some dummy API there. Let me actually show you how it looks. I can send a request, and this is what my car API will return me back. So some API telling me that I have two cars, Fiat Multipla and Renault Clio. And this is basically the request to get the voting application HTML page. Okay, so this is what I have inside my Kubernetes. Now, this is my third experiment. Let me edit it and show you what I have inside. Here I will have again one step, one branch, but now I'm injecting this failure on the Kubernetes level. I'm using basically the Chaos Mesh pod chaos, as you can see, and this is the specification of what needs to be inserted, the specification of what I actually want to do. As you can see, I will run an action called pod failure for all of the pods. I will run it for 10 minutes, and the selector will be the namespace default. So basically for all of the pods that are in the default namespace for 10 minutes, I will emulate or like inject a failure. I would like to make actually one highlight here as well, is that if you worked before with the Kubernetes and with the Chaos Mesh in particular, you know that the default format in that community is the YAML format, but here you see some JSON. So technically that's still the same structure, the same format. The difference is here is that all of those experiments that you can run, you can actually create them automatically through the automation. That basically means that if you have, let's say, a template that describes your experiment, you can deploy that template with that experience to subscription 1, 2, and so on and so forth. You can easily move them between the subscriptions in that way. But Microsoft, underneath on their management API, they are using not YAML but JSON. So the only thing that needs to be done here is just to create the same specification that you may already be familiar with for the Chaos Mesh, and then just convert it from YAML to JSON. No other alterations are needed. So this is my experiment here, and I will run it momentarily, but before that I will show you this last tab here. So this is the availability test. I have two of them actually. I have the webping, which will be basically calling the page of the voting app, and this guy webping2, which will call the API. And therefore what my expected behavior here is that as soon as I will run my emulation, because I will destroy all the pods in my default namespace, okay, not destroy, but I will emulate the failure of those pods, then the webping2 should basically show that my application is unavailable, but at the same time webping, the regular one which calls the routing API, should work as expected. So let's actually do this, but even before that, I want to show you probably another thing also. Want to show that explicitly. So this is the page, this is the current state of my cluster. As you can see, everything is green. Let me refresh it again. Everything is green. Now what we are doing, we are starting this experiment. And as I was saying, it may actually take some time to start. It may take, I don't know, maybe like 15 seconds, maybe even up to 1 minute. But nonetheless, at some point it will run, and when it will run, on this dashboard here, we'll be able to see that our catalog API, which is in the default namespace, is failing. Let me try to refresh this guy. Yep. As you can see, it's already failing, and let me get back actually to my Visual Studio Code. I can again call, as you can see, my voting app, and my voting app is still responding with the HTML page. But if I will try to call my catalog API, as you can see here below, it's still waiting, and at the end of the day it will just basically throw an error. I expect it to be the timeout error after maybe like 60 seconds or something like that, saying basically that sorry, we were unable to get any response from that host. Yep, as you can see, nothing is happening. Let me try that again. Yeah, request timeout. Let me try that again, but still that will be the same. This request will time out. And we will do some fast forward, and we will see basically the same thing on our dashboard, where we have the metrics from the application inside, the web availability tests, and then in 10 minutes I will get back and explain a few more things about this experiment. Okay, I do believe our experiment is over. Let's try to refresh this dashboard. Yep, as you can see, exactly what we've expected. At some point we started to receive those failures on our web availability test, and those failures were for web ping too. Yep, as you can see, there is a gap in availability, but for web ping everything was fine. The thing that I wanted to highlight here is that now I kind of destroyed my application entirely, and there were no fail-safe, nothing like that, so that's why we were unable to recover and we failed. But the idea here is that you can run your chaos engineering tests for your application that runs in Azure, and what will make a lot of sense is to basically schedule a lot of different scenarios. The thing that I showed you today, there were only, like one scenario with one step and one branch. But let's say that what I want to do, I want, for example, to, as in my current example, destroy all the pods in the specific namespace. Then I would like to add one more step, and here I may say that I would like to add a delay for 10 minutes. Okay, and then I want to add another step, and this step will be about something entirely different. Now I want to, for example, I don't know, let's say, do the CPU pressure on my virtual machine, and at the same time, together with the CPU pressure, I would like on my Cosmos DB database to run the failover again through Central India, for example. So you can plan all of those scenarios, you can implement all of those scenarios from here, and then you can run them and basically see how your application will perform in those cases. Because, again, what I said at the beginning of this presentation is that the main purpose of chaos engineering is to basically build enough confidence that on production you will be run your application no matter what. That's it that I have for today. Thanks for your attention, and the last but not least, I would like to invite all of you to join me at the Q&A session.